Hello, welcome to the first session of our class on computer systems and networks. Today, we will go over internet fundamentals. Some key terms for you to know: networks, internet, clients, servers, routers, packets, and nodes. Now, obviously, you've heard of the internet before. We're using the internet right now. You're on the internet to watch this video. But we're going to study it a little bit more in depth so you can know the more precise definition. Learning goals. By the end of today, you will know what a network is, what the internet is precisely, how clients and servers communicate, how packets travel across networks, and how information moves around the world. So first, to get started, imagine this. You send a text message to your friend. How do you think it travels? Does it go directly from you to your friend? Hmm, what devices might help move the message along? So go ahead, you can pause the video, write down your answers. We'll revisit this topic in a moment. First, network. What is a network? Here's the definition. A network is a group of connected devices that can communicate with one another. So what are some examples of networks? What do you think? Go ahead and pause the video now. Write your answers down. Some examples: school Wi-Fi. Now, for my full-time job, I'm working in an international school, and we're all connected to the school Wi-Fi. Teachers, staff, the principal, and students. Home Wi-Fi. Perhaps in your home, you'll have the father looking at his stocks, the mother reading an article on like some sort of magazine, the brother playing some games, and then the sister watching some funny videos on YouTube. Maybe an office network. All the coworkers in an office share the same network, connecting to each other or doing business together. Next, what kind of devices do you think can be part of a network? Go ahead. Again, pause the video, write them down. Here's some examples. Of course, computers, smartphones, tablets, and hey, even wireless printers, etc. So on any single network, you can have all of these connected to it. Computers, tablets, printers, phones, etc. Now, some questions for you. Number one, what is the minimum number of devices needed to be considered a network? Number two, what is the maximum number of devices that a network can handle? Go ahead, write down your answers. So, we need at minimum two devices to be considered a network. If you're like me and you have an iPhone, there's a feature on the iPhone where if you connect it to another, put it physically next to some other iPhone, you can send pictures or videos or other information directly. When you do that, you've effectively created a little mini network. As for the limit for the number of devices, there's no theoretical limit, but we do have practical limitations determined by bandwidth and other limitations of your network. Usually, for a home Wi-Fi, about 20 so devices are, you can have up to 20 devices or so. School network, possibly hundreds of devices, maybe if you're in a medium-sized high school, or thousands if you're in, for example, a university. A large company network. Imagine you work for Microsoft or IBM or McDonald's corporate. Well, you can have tens of thousands of devices connected. And the internet. The internet is one big giant network. And of course, there are billions of network devices connected worldwide. Next topic is the internet. Now, of course, so what is the internet? Of course, you have a very good intuitive understanding of what the internet is. Basically, the internet is a network of networks. Think about this. Your home network is connected to the internet. Your school network is connected to the internet. Everything is connected somehow via the internet. So millions of smaller networks, your home, your school, a company, public Wi-Fi, they're all connected together by the internet. Ta-da! Here's a graphical representation. So what are some things that you use the internet for? This is not a trick question. Why don't you go ahead and write down your answers? So for me, I use it for things like web browsing, sending and receiving email, video streaming, and cloud storage, and more. Okay, next thing, question. Who is in charge of the internet? The answer is nobody. There's no one president or dictator or leader of the internet. It is decentralized. The internet is a global system that connects billions of devices. Next topic is client and server. So you probably have an intuitive idea of what the words client and server mean. But in this context, what are they? First, what is a client? Any clues? Here's the definition. A client is a device that can request information. So think about your computer. What are your favorite websites? Instagram? TikTok? The New York Times? The Economist magazine? Whenever you go to, so nothing from TikTok or Facebook or Instagram is stored on your computer unless you decide to download it. That means every time you go to Instagram.com and visit your friend's page, you are requesting information from somewhere else to be sent to your device. Your device is therefore a client. Your phone can be a client. For me, I use my smartphone. I browse the web, I surf uh, newspaper articles, and I ask ChatGPT a bunch of random questions. Your laptop, of course. For me, I'm currently using my MacBook Air. Your tablet. These are all examples of clients. On the flip side, what is a server? Well, if my smartphone is going to Instagram or going to New York Times or The Economist, is asking for information. Asking who? Well, that's where the server comes in. The server holds that information, and then we request information from the server. The server gives it to our client device. So Google has servers, YouTube has servers, Netflix has servers, etc. So whenever you visit a website, your client device makes the request, and the server provides a response. This is known as the request-response cycle. And yes, request and response are both technical terms. So here's what it looks like. Your laptop goes to google.com and says, hey, Google servers, give me what this page looks like. And voila, you have it here. Questions for you. Which device is usually the client when you visit YouTube? Go ahead, write that down somewhere. Again, this is not a trick question. When you watch a video online, what information might the client request from the server? Why do you think companies use powerful servers instead of storing websites on individual users' computers? So go ahead and pause the video and write down your answers. So pause. Now you start it again? All right. So for number one, basically whatever you use to type in youtube.com, whether that's your smartphone, your laptop, etc. When you watch a video online, you'll probably request the following from the server: the video itself, and maybe some metadata about it. Why do companies use powerful servers instead of storing websites on individual users' computers? Well, first of all, that's a security risk. Secondly, you would then be relying on customers for your websites. We don't want that. So what are some websites you like to visit? Go ahead, write them down. For me, perhaps more than I like to admit, Instagram. I don't use TikTok, but maybe some of you do. And YouTube. I love watching YouTube videos. Every website follows the same basic process. So every time you go to a website, you follow this process. One, your computer acts as a client. Two, the client sends a request. Three, a server receives the request. Four, the server sends information back. Five, the web page appears on your screen. So memorize this because, ta-da, pop quiz. Can you put these in the correct order? Go ahead, pause the video. Just write down the letters. Like maybe it's C, D, A, B, or something like that. Just write down the letters. The answer is B, E, D, A, C. Okay. So next topic is this. First question, what's going on here? That's right. There is a traffic controller directing traffic. If basically the policeman says you can go, then you can go. If the policeman says do not go, then do not go, right? And the policeman can tell you where to go too. Basically, in that case, a traffic controller is like a router. And that's the next topic. What is a router? Well, a router helps move information between networks. You might have one in your home. I have one over here. Let me take a picture of it and I'll show you on my phone. So here's my router, okay? And here's where, yes. So think of the router like a traffic director. A router receives information, decides where it should go, and then forwards it to the next destination. Without the use of routers, information would not know where to travel. Question, what is the job of a router? Why might a message need to travel through several routers before reaching its destination? If one route becomes crowded or unavailable, what should a router do? So go ahead, pause the video, answer these questions. All right. Job of a router decides where information goes. Why might a message need to travel through several routers? So think about this. I have a router in my home. It has a very limited range. Hey, I go to my bedroom, and when I go to my bedroom, the signal gets weaker and weaker. There's no way my router can get information to you wherever you are. Maybe you're in Canada, maybe you're in the USA, maybe you're in Taiwan. If one route becomes crowded or unavailable, what should a router do? It'll look for a different route. So here is a graphical representation. Maybe you're here and I'm here. Well, you're too far from my router, but what my router will do is send it to A will send it to C will send it to F, and you get the information. But wait, A goes offline. Well, what do we do next? Send to D, and then send to C, and then send to F. Okay? Next thing is this, packets. Now, I'm not talking about a packet of ketchup. When you're sending information across the internet, it doesn't get sent all at once. It gets sent in the form of small pieces known as packets. Each packet contains this part of the message, that's the data, the source address, which is you, the destination address, which is the person receiving the message. Instead of sending one huge file all at once, the internet sends many small packets. Why is that? Well, information is faster communicated and more reliable. So next thing is this, how do packets travel? Let's say you send the word hello in all caps. The message may be divided into packet 1, HE, packet 2, LL, packet 3, O. Each packet actually may go into a different route, but ultimately, when they arrive at the destination, these packets, which can arrive out of order, get reassembled into hello. So here is an example of a packet. Okay. If you'll see, there's something called a checksum here. That's to double check if you have an error or not. Right, so there's some Python as well, but I think I'll save Python for another time. So with that said, thank you very much for today. Thank you for watching.